Welcome back to our video classes. Today is the third lesson on the topic real numbers, chapter 1. Previous classes we discussed about fundamental theorem of arithmetic, LCM, HCF, all these we discussed, and today we are continuing with the same topic only. So we are continuing the exercise 1.1, question number 16. Explain why 7 into 11 into 13 plus 13 is a composite number. So you know the fundamental theorem. In fundamental theorem it states that every composite number can be expressed as the product of primes. As the product of primes. Every composite number can be expressed as the product of primes. So we can do the reverse of this. If you can write any number as the product of prime numbers, then you can say the given number is a composite number. This is what we are doing. And check this number, whether it is product of primes. You can see this is multiplied, so it is product. But when you come to the last part, it is plus. So it is not perfectly product of primes. So we have to express this given number as product only, not the sum. We have to express this as the product of primes only. That is 7 multiplied by 11 multiplied by 13 plus 13. We don't want this plus. We need only product. So what are the two methods I will explain. The first method is you can take these are two terms. You can treat as two terms. This product is one term and plus 13 is the second term. From these two you can take 13 common. When 13 is taken common, what is remaining in the bracket? 13 is taken common, so what is left out here? 7 into 11 is left out, and then you have to put the sign plus. The 13 is taken common, that means 13 is simply 13 into 1. When 13 is taken common, 1 is left out. Then we can write 13 multiplied this. It is 77 plus 1. We can write 77 plus 1. So 13 into this is 78. So we can see now it is only product. 13 is prime but 78 is not prime. It's a composite number, but every composite we can write as the product of prime. So 13 into this 78 you can factorize. You can factorize this 78 as divided by 2. It is 39 divided by 3. It is 13 divided by 13. It is 1. So it is 2 into 3 into 13. Or we can write 2 into 3 into 13 comes 2 times. So it is 13 square. It's a product of primes. It is a product of primes. This result is a product of primes because only multiplication symbol is there. Since the same number we can write as the product of primes. Since it is product of primes, therefore by fundamental theorem of arithmetic, the given number is composite. Why it is composite? Because that number can be written as the product of primes. Okay. Then the second method we are explaining. The second method is that method 2 we can write. The second method is that 7 multiplied by 11 multiplied by 13 plus 13. What you have to do is multiply all these first. You can multiply it. 11 into 7, 77 into 13, 77 multiplied by 13, multiplied 21, 23, 77, 1, 0, 10. 1, 0, 0, 1 plus 13. This product is 1, 0, 0, 1 plus 13. So 1, 0, 1, 4. This you can factorize 1014, you can factorize it as by 2, it is 507, then divided by 3 because the sums 5 plus 0 plus 7 is 12, 12 is divisible by 3, so it divided, it is 169 divided by 13, 13, 13, 1. So it is 2 into 3 into 13 square, because 13 comes 2 times, so it is a product of primes. This is a product of primes. Product of primes. Therefore, the given number is composite number because of fundamental theorem of arithmetic. So this way also we can write the answer. Okay. Yes, this board exam one question was that P into Q into R plus R, where P, Q, R are different prime numbers. They are different prime numbers. Then what about this result? Okay, first one is explain why this is composite. Okay, so if three prime numbers product plus one of the prime number from it is coming here, it will be always composite. Explain. You can explain in two ways. By taking example you can explain, or you can do it like this. Treat these two as two different terms and take common. What is common to both? R is common, multiplied, what is left out? When R is taken common from P into Q into R, PQ is remaining, so PQ plus here R symbol means R into 1, so R is taken common, so 1. So this is a number and this is another number. This second number may be composite or prime, it doesn't matter. If it is composite, we can further factorize it into primes. If it is prime, okay, prime. So this is a prime and R is already a prime, so this is a product of primes. This is a product of primes. So by fundamental theorem of arithmetic, the given number is a composite number. This way you can answer. Another method, take some values for P. Let P is 2, any number you can, any prime number you have to take, because it is told to us P, Q, R are primes. P is 2, Q is 3, R is 5. Okay, we have taken the first three primes itself and put the values 2 into 3 into 5 plus 5. Then you can directly multiply all this. Other way you can take common factor, otherwise you have to multiply this. You get 2 5s are 10, 10 3s 30 plus 5. It is 35. If you factorize, you will get 5 into 7. This is the product of primes. Product of primes. So by fundamental theorem of arithmetic, it's a composite number. Yes, listen. If 3 or more, it is not necessarily P into Q into R. Maybe R, S, T or many prime numbers are multiplied and added to one of the prime from this. Then it will be composite only. But if 1 comes here, instead of R, in R's place Q can come, P can come, any one of this prime is added here, it will be composite. If 1 comes, both possibilities are there. Sometimes it is composite, sometimes it is prime. Okay, we have to prove both the situations. When it will be composite, give an example. When it is prime. Okay, when you want to prove the number, the product and plus 1 is prime, you have to take one of them is 2. Either P or Q or R. Q is 3 and R is 1. R is 5. 1 you should not take 5. Then you put the values 2 into 3 into 5 plus 1. It is 2 5 is 10 into 3 30. 30 plus 1 31 is prime. Why it is so? When 2 comes, definitely this will be an even number. when even number is added to 1, there is a possibility that it will be prime. So if you take 2, possibility of getting prime is higher. And if you want composite, don't take 2. Okay, I am taking P is 3, Q is 5, R is 7, and let's try. It is not compulsorily it will come. Okay, let's try this. 3 into 5 into 7 plus 1. 3 into 5, 15, 15 into 7, it is 105, plus 1, it is 106. 106 is an even number, or we can factorize this 106 as divided by 2, it is 53. 53 is prime, so 2 into 53. It's a product of primes. Product of primes. It is product of primes, so it is composite. Okay, this way we can do this. Yes, next question, question number 7. It speaks about a circular park and people are making rides in their motorcycle or cycle. The first person is Sonia. She can make a round around it in 18 minutes. Sonia can make a round around it in 18 minutes. Ravi can do the round in 15 minutes. Ravi is faster. Okay. So they both of them start from the same point, starting point. They move around the park. When they move, Ravi will be faster, so Ravi goes ahead. Ravi completes one round in 15 minutes. Then Sonia is not completing the round, she will be little behind. And then Ravi goes ahead and covers some distance. Then only Sonia will complete one round. And it continues like this. The question is, after what time they will come together in the starting point. Okay, we can take Sonia is completing one round in 18 minutes. And second round she completes in the next 18 minutes. That means the second round she will take another 18. That means 18 plus 18, 36 minutes from the beginning she will complete the second round. And then third round she will complete in 54 minutes like this. Ravi completes it in one round in 15 minutes, second round in 30 minutes, third round in 45 minutes, fourth round in 60 minutes. Okay, like this it goes. 60, then fifth in 75 minutes, then 90 minutes, like this. And here 36, 54, then 72 and 90 and goes on. Okay, when Ravi one round completes in 15 minutes, second round in 30 minutes, 45, third round, fourth round, fifth round, sixth round. When Ravi completes sixth round in 90 minutes, Sonia completes one round, two round, three round, four round and 5 rounds. When Sonia completes 5 rounds in 90 minutes, Ravi also completes 90 minutes and reaches the starting point by the time Ravi has completed 6 rounds. But that doesn't matter. Question is when they will meet again at the starting point. Okay, then we have to find the LCM. LCM of this. LCM of which numbers? 18 and 15 we have to find. Okay, you can write it like this way also, you can write it, but better is the textbook method. 18, factorize this, you get 2 into 3 square like this. 18 is factorized by 2, 9, 3, 3, 3, 1. And then 15 you have to factorize by 3, 5, 5, 1. 15 is 3 into 5. Then find the LCM. LCM is the product of prime factors with the highest powers. The highest power is 2 raised to 1. Even if it is not common, you have to take the highest power. In 3 is highest power, 5 is highest power, and multiply and write 2 into 5, 10, 10 into 9, 90. So in 90 minutes, both will come back in the starting point. Okay. Another question. There are 3 traffic lights. Okay. This is one light, light 1. This is light 2. This is light 3. 3 lights are placed in 3 corners. And at 5 a.m. in the morning, 5 a.m. in the morning, all 3 lights light together. And then it gets off. Okay. 45 seconds. After 45 seconds only, the first light will light again. Second light will light again after 75 seconds, and third light will light again after 60 seconds. Instead of light, it may be an alarm also. Alarm, first alarm, second alarm, third alarm. All 3 buzz together at 5 a.m. Suppose the first alarm rings after every 45 seconds, second one rings every 75 seconds, third alarm rings after every 60 seconds. Then after what time? After 5 a.m. when it will ring together or when they will light together. So 45 seconds it is lighting the first light. Then after that it will light in 90 seconds. That means after one more 45 seconds, and then 135 seconds, like that, because when the light is lighting after every 45 means it becomes the multiple of 45, it goes on. And then it is 180 seconds, then it comes 225 seconds, it goes on. And the second light will light in 150 seconds, then 225 seconds. Third light 60, 120, then 180 and 240. It goes on 300. Okay. Like that here also 300 seconds. This one it is 270. Okay, then 315 seconds and goes on. You can write it like this. At times you can see at 225 seconds or 180 seconds, these two are lighting together, but all 3 when they will light together, for that you have to write the multiples like this. When all 3 are same, then we can write. Or from this what you can understand that we are writing the multiples and then we find the common multiple, or what we can understand the final result is bigger than the given numbers 45, 75 and 60. So whenever you want to find a number which is bigger than the given numbers, what you have to find? LCM, because LCM is bigger than the given numbers. Find the LCM. For this we take factorized form of 45. 45 means 9 5s are 45, you can write 3 square into 5. 75 is 5 square into 3, 25 3s are 75, 3 into 5 square. 60 is 2 into 3 into 2 square into 3 into 5. Okay. 2 square is 4, 4 5s are 20, 20 into 3 60. So find the LCM of this. LCM is the highest power you have to take in 2's. What is the highest power? 2 square. In 3 is highest power 3 square. In 5 is highest power 5 square. You can take 2 common from all powers and multiply and then square it, or that means take whole square, because 2 is the power of whole, you can take it common, then multiply 2 into 3 into 5. 5 2s are 10, 10 3s are 30, 30 square, it is 900. Or if you are not understanding this, 2 square is 4, 3 square is 9, 5 square is 25, 25 4s are 100, 100 into 9, 900 seconds. That means at 900 seconds or after 900 seconds, all the three lights will bright up again or light up again. So this 900 seconds means how many minutes? 60 seconds will make 1 minute. So you divide 900 by 60. 1 times 60 and 30, one more 0 is coming. It is 5 times. It is after 15 minutes they will ring together. In the beginning, all the lights were bright up at 5 a.m. When they will bright up next time? Next time is 5 hour and 15 minutes or 5:15 a.m. they will light up again. Instead of light, it may be the alarms. Okay. If there are three vessels of different capacities are given, in one of them we can keep 50 liters of milk, other one we can keep 80 liters of milk, other one we can keep 60 liters of milk. Then what is the size of the measuring vessel with which we can measure the milk of all the containers in complete number of measurements? That means if you bring a cup of 1 liter, how many times you can empty this? By how many times we can empty this first vessel? 50 times you can take out and empty, then no milk is left out. And 1 liter vessel, if you use 80 times you can take out. From here 60 liter. But the question is, what is the capacity of that maximum capacity of the vessel? That it can empty out all the vessels in complete number. That means no milk is left out, or no half vessel or half measuring vessel is filled. So what is that? So definitely you can understand, when you take the measuring vessel is never bigger than the given container capacity. So this is a smaller one. Whenever it is asked to find something smaller than the given numbers, the name is HCF, but is a factor. So HCF is always smaller than the given number, smaller or equal sometimes, smaller or equal to given numbers. So we can neglect about equal when we do the word problem. So we can understand HCF. We need a smaller one, so we have to find the HCF. 50, we factorize it, 2 into 5 square. 80 is 2 raised to 4 into 5. And 60 is 2 square into 3 into 5. We have written 2's together. What is the HCF? HCF is coming only in common factor with the smallest power. In 2's, what is the smallest power? 2 only. In 5's, what is the smallest power? 5. So we will take 10 liter vessels to empty this. If you take 10 liter, it will be emptied in 5 times, this will be emptied in 8 times, and this will be emptied in 6 times. This type of many questions are there. Instead of this, there may be a room. A room is given. Okay, a room. Its length is 10 feet. Breadth is 8 feet. Height is 12 feet. What is the length of the measuring rod by which we can count this in exact number of times? So we have to find it. Do you take a rod which is longer than the length of the room? No. We will take a rod that can measure this length in exact number of times, means many number of times we have to keep the rods along the length, along the breadth, along the height. Okay, so definitely the measuring rod is smaller. So read the question, understand whether we have to find a number which is bigger than the given numbers or smaller than the given numbers. I will share some 7 standard questions related to LCM and HCF so that you will understand better. So by this we can wind up the first exercise. Next class, that means on Monday, we will do with irrational numbers. Okay, Monday and Wednesday we will end this chapter and we will go to the next chapter. Thank you.